Let's have another example. The electric motor of a model train accelerates the train from rest to 0.620 meters per second in 21.0 milliseconds. So that's milliseconds. The total mass of a model train is 875 grams. Find the average power delivered to the train during its acceleration. So nado kay train. So mag-drawing sa train ha. Actually, it is not necessary to draw a train. So for example, this is a train. Yan. Example lang na ha. So, na akong train eh. And then, after some time, the train reaches this point. For example lang na. Okay. So now, let us identify all the given variables, given values. An electric motor of a model train accelerates the train from rest. So, ibig sabihin, the train starts from rest. So, ibig sabihin, the velocity at this point is 0 meters per second. From rest to 0.620 meters per second. So that means there is a velocity here. So that is our final velocity, which is 0.620 meters per second in just 21.0 milliseconds. So that is the time taken from 0 to 0.620 meters per second. So the time taken is 21.0 milliseconds. So take note of that prefix that is milli. And what is milli? That is equivalent to times 10 to the power of 3, a negative 3 seconds. So that is 21.0 times 10 to the power of negative 3 seconds, because milli means times 10 to the power of negative 3. Remember the prefixes that I introduced to you during our first lesson in physics. So milli, micro, kilo, hecto, deci, giga, mega. So those are the prefixes that you need to be familiar with. Okay. Now, the mass of our train is 875 grams. Now, take note, this is not yet in a standard unit. So that means we need to convert this into standard unit, which is kilogram. So 875 grams is equivalent to 0.875 kilograms. Yeah, so make sure na all the units in our given are in standard units. So SI units dapat. Okay, so the required variable is the power. Ayun, find the power, the average power delivered to the train. Power is unknown. So that means if power is unknown, babalik tayo doon sa equations ng power. So first equation ng power, we have power is equal to work over time. And second equation, we have power, which is force times displacement over time. And then the third equation, we have power is equal to force times velocity. So let us identify the which equation will be useful to our problem. So ang given natin, meron tayong dalawang velocities because it is referring to acceleration. So make sure na hindi kayo ma-confuse dito sa third equation ha. Baka kasi third equation yung gagamitin yung equation. Hala, may velocities. No, you are going to use this third equation if the velocity is constant. Okay, so that means our object moves with constant velocity. So in this case, we cannot use the third equation because the train, the model train is having an acceleration. So hindi pwede. So ano yung gagamitin natin dito? Hala, wala lagi. Okay, so balik tayo doon sa lahat ng napag-aralan natin. Pwede ba na work? Ano ba yung mga formulas natin sa work? Force and displacement. We cannot use that because there is no displacement in our given. There is no force in our given. How about work? What are the other equations for work? Aha. Meron din tayong equation ng work. If you remember, we also have an equation work is equal to uh, the change of kinetic energy. Tama no? 1 half mv. Mangita lang ta actually og equations nga mag-fit sa ato ang problem. So 1 half vf squared minus vi squared. Meron din tayong equation sa work dito kasi kailangan natin ng work. Meron na tayong time. So pwede na yung time na yan. Ang work na lang. So check muna natin if this equation for work can be used in our problem. Do we have mass? Yes, we have mass. Ayun, check. Do we have final velocity? Yes. Do we have initial velocity? Yes. So that means we can calculate the work using the work energy theorem. So pwede pala si work. How about time? Yes, there is a given time. So that means we can use this equation. So we are going to use equation number 1. However, before we can use equation number 1, it is very important to solve the work first. Kasi wala mang work na given using the work energy theorem. Kasi lahat ng variables dito given sa ating problem. So that is 1 half times the standard mass, 0.875 kilograms times the initial velocity is 0, so this can be disregarded, times the final velocity is 0.620 meters per second squared. And that will give us pila 0.620 squared times 0.875 divided by 2. That will give us 0.168175 joules. Okay, so this is our work. Remember, do not yet round it off because this is not our final answer. We are looking for the power. Okay? But take note of the number of significant figures. Pila lang ni ka number of significant figures? Tulo. So it should only be until 8. Okay, so since we already have work, then that means we can already solve for power. Ayan. So power is equal to the work over time. The work is already being solved. That's 0.168175 joules with 3 significant figures only, divided by the time, which is given. That's 21.0 times 10 to the power of negative 3 seconds. Remember to use the standard units. And that will give us pila. Divided by 21.0 times 10 to the power of negative 3. And that will give us 8.0083 joules per second. Ayan. Kasi joules ang naiwan sa taas, seconds ang naiwan sa baba. So how many significant figures? We need 3 significant figures. So power is equal to 8.01. What is joules per second? That is equivalent to watts, or the unit of power is watts. Yan. So this is our final answer. Okay, di ba? Dali lang, no? So ang pinaka-importante is we just find ways kung ano yung formula na pwede natin magamit. Of course, apply natin yung lahat ng na-discuss natin from the first semester. Okay? Ayun. Okay na? So if you have questions, never hesitate to contact me via Messenger.